Hey, sixth graders, welcome back to the second half of this lesson. This is lesson 11. We're going to start here on page 211. And before we get started, I was just going to tell you guys um, I just recorded a whole video and realized that I did something wrong, and so here I'm going back and I'm doing it again. So if I skip over something or you feel like I'm going too fast and you miss a concept, or if I forget to say something, just send me an email. Hit me up on Teams. Just say, Mr. Babinski, I really didn't understand something. Can you explain this? And we'll go back and we'll do it again, okay? So we've been talking about unit rates and these double lines and this dependent and independent variable. Remember, the dependent variable means that it depends on something else. The independent variable means it does not depend on anything. It does not change. There's no change happening to it, right? So we're starting with suppose student 4 walks at a constant rate of 7 feet for every 2 seconds. That's really important information here. What this is saying is that for every 2 seconds, 1, 2, I'm going to travel 7 feet, right? So let's draw it out. Sorry, let me get rid of that real quick. So just keep in mind, I'm going to highlight these in different colors. Our green, we have, so blue. Okay, so we have distance and we have time. As time goes on, distance is changing, right? As this time goes forward, the distance that we're walking is changing, or the distance that student 4 is walking is changing. So we know how much at 2 feet or 2 seconds. What we're trying to solve is how much at 1 second, and in better yet, how much at a half a second. So per second, so I need to figure out what times 1 is this unknown amount here, right? So I know that half of 2 is 1, and so that tells me that half of 7 is how I can solve for x. So I can do 1/2 times 7, which gives me 3.5, right? I can just write in 3.5, and that's a pretty simple one. If we do it this way, if I do half of that, I get 1.75. If you don't believe me, check me. Half of 3.5 is 1.75, and that's where it lands right here on this time, or this timeline. So now it's asking me, well, okay, that's good for 1 second and half a second, 2 seconds, but what about 4 seconds? What about down here where it says 4 seconds? Now we need to know, how far have I walked, or how far has student 4 walked after 4 seconds? So we're going to need to count 1, 2, 3, 4. Luckily for us, this has us counting by 2s. 2 seconds is 7 feet. 4 seconds is, and I just double that, which is 14, right? 14 feet. Another way that I could do this is I could go down to the chart and I could say, well, for every 2 seconds, I travel 7 feet, right? And actually, I don't need to write feet because it's right here. It says it already. This is the one time I'm telling you not to write your units in, and it's okay. A scientist would just leave it in if it was already written in. So now I need to solve. So now, so here, I need to know what to multiply this by. 2 times what is 7, right? So let's write that over here. 2 times a number is equal to 7. So now I need to figure out, how do I solve for this 1? I could figure that out by getting this variable by itself. And if I divide that, these go away, and I'm just left with t. 7 divided by 2 is 2, 4, 6, 3 and 1/2, or 3.5. And if I go up here coincidentally, That's my answer, 3.5. And so I'm just going to write it in here, 3.5. Now I have a rule. Obviously 3.5 times 0 is 0, right? So now I have a rule to base this off of. And I can solve for all of these. 3 times 3.5, well, 3 times 5 is 15. Carry the 1. 3 times 3 is 9 plus 1 is 10. It's 10.5 times 3.5 times 3.5. So we can solve for all of these. And I could even say, well, at 45 seconds, how many feet will this student have walked? And all I have to do is multiply 45 times 3.5, right? Okay, and I'm not going to calculate that, but we could if we needed to. So now it's asking me what is the unit rate for this, and I'm going to give you a real simple answer to unit rate. Remember back to 4th grade. In 4th grade, we talked about unit fractions, and we talked about something to unit ratios. I think we talked about at the beginning of the year. So this is unit rate. A unit rate is at 1. What is the answer? What can I multiply by 1, or what can I get it at the simplest form? And that's at 1. 1 times 3.5 is 3.5. So for every 1 second, 3.5 feet is, and that's where our rule comes from. That's where this comes in. And that's what makes it simple for the rest of these, right? Okay. So my unit rate is for every 1 second, that's how many are traveled. So I'm just going to put 3.5. Whoops, that's not writing. 3.5 feet. Or you could do it in fraction and you could say 3 1/2 feet. Though I prefer decimals. That's just me. Okay, so write an equation relating to d and t. Well, if I look at that, it's just 1t times 3.5, sorry, 3.5t. Let's just write this, 3.5t equals d, right? Now, I easily could have said that this was my equation. This, I'll rewrite it, 2t equals 7, because that's what we started with. For every 2 seconds, we travel 7 feet, right? But that's not our unit, that will not get us our unit rate. We want this to be 1t or 1d. And right now this is 7. D equals 7. I don't want that. I want what times t is equal to d. And so I need to do 3.5t is equal to d. Okay, so then we can start plugging in numbers. And all I have to do is, in this equation, just plug it. So 3.5 times 3 equals d. Can I solve for d now? Heck yeah. 3.5 times 3 is 10.5, right? Check my work. 3 times 5 is 15. Carry the 1. 9 plus 1 is 10. Move the decimal over once. Circle my answer. Okay, same thing over here, 2.5. 2.5 I can actually make into a mixed number by multiplying 2 times 2 is 4, plus 1 is 5.5. Now I can plug in that 3 times 5.5, or sorry, 5 halves is equal to d. This is pretty simple. 3 over 1 times 5 over 2 is 15 over 2, which can be rewritten as 2 goes into 15 equally 7 times with 1 left over. Circle my answer, right? Okay, good. Okay, so this is tricky. This can get tricky, and I'm going to need to use a double line to explain this to you. Suppose student 5 walks at a constant rate of 11 feet every 3 seconds. So I'm going to draw my double line over here because that's the tool that we're going to use. This one represents, whoops, let's just say distance. I'm already messing it up. Distance, and this one is time. So at 0 distance and 0 seconds, right? Well, we can just leave it like that. So here's 1 second, 2 seconds, 3 seconds, right? Up here, let's do this in a different color. Let's do this in blue. We have 1 blank blank. We don't know how many feet this is, right? So let's call this X. We don't know that number. We don't know this one, but we do know that one. It's 11, right? For every 3 seconds, 11 feet was traveled, okay? Okay. So I need to figure out, how can I solve for X? How can I get that unit rate all on its own? There are a couple of different ways, and what I did was I said, I'm going to use the information that I have available to me. I know that for every 3 seconds, I have 11. For every 3 seconds, and this changes, this is my dependent variable, right? I'm trying to solve for this. For every 3 seconds, I travel 11 feet, or the student travels 11 feet. I want to know, how do I get this t all by itself so that this is 1t equals something? And I can solve for that. And it's very easy for me to solve for this, in fact. So I'm going to divide this side by 3 to get that t all by itself, right? Because 3 over 3 is the same thing as 1, but I don't need to really write that 1. It's invisible. Doesn't matter. So let's get rid of it. Is equal to, well, I need to divide this side by 3 too, because that's how we keep equations equal or balanced, right? So 3 goes into 11, 3, 6, 9, 3 times with 1 left over. No, that's not right. 9 minus 11 is 2 left over. Okay. So now I have a brand new equation. I now know that x is equal to 3 2/3. So now I can rewrite this over here. I'm going to rewrite it over here. It's 3 2/3 t equals d, 1d, right? Because we're solving for distance. So 3 2/3 t equals d, or d, distance, is equal to 3 2/3 times seconds. And I did not write that correctly again. Oh my goodness, what is wrong with me today? Okay. So calculate how far student 5 walks in the given length of time. So I'm just gonna plug these. I'm just gonna plug that right in there. I'm gonna plug that right in there, right? So I have 3 2/3, which I prefer to rewrite as a mixed number, or I'm sorry, not a mixed number, but what do they call those with the number greater than 1? I don't know. Brain's not working. 3 times 3 is 9, plus 2 is 11/3, right? Times 6 seconds equals, I'm just going to put this, 11 times 6 is 66, 3 times 1 is this. So my answer would be 33. Nope, that's not correct. It would be 22. Whew. I'm getting there, guys. I'm getting there. Okay, so 22 is my correct answer. And I know that because 66 parts of 3 looks also like this, right? 2 times 3 is 6. 2 times 3 is 6. That leaves me with 22. Okay, number 20. Same deal. I'm going to do this in a different color so I don't get mixed up, though. 3 and 2/3, or we decided that was 11/3, right? So let's write 11/3 because it just makes the math easier. Times 7.5, that's 7 times 2 is 14, plus 1 is 15 over 2. Multiply straight across. 11 times 15 is, whoa, what is 11 times 15? I'm going to have to do this by hand. Plus 165. Times 2 times 3 is 6. Don't even worry about that. I'm just going to write 165 over 6. That's perfectly acceptable to me. Okay. So we're going to get a little bit more challenging. It's going to get a little bit more challenging here. Suppose the student walks at a constant rate of r feet per second. R feet per second. Label the double number line below for the student and discuss why the equation is d equals r times t relates the distance, the rate, and the elapsed time for the situation. All right. So it's unknown to us, right? All that we know here is our seconds. That's the only thing that is available to us right now. We don't have any other information, right? So this is a lot simpler than you would think it is. I'm going to do this in, let's do this in orange. This is R, right? If 1R, this basically looks like 1R. This would be 2R and 3R and 4R, 5R. Why is that? Why does it look like that? Can you think of an explanation for why that might be? I want you to try this on your own. I want you to do number 22. Go ahead and push the pause button real quick, and then we'll go through the answer in just a second. Okay, welcome back. So, I just wanted you to give me a summary or a written response or a written explanation for why this is 2R, 3R, 4R, 5R. And the best thing that I can come up with is the distance. Let me zoom in on this so that I'm writing better. I'm sorry. The distance walked is, oh my gosh, equal to the product of the elapsed time and the unit rate. Okay. So what that means is that if R is 1, then it has to be 2R, 3R with direct respective to time. So, and that's just how it works. So, okay, guys, that's it. I want you to go and finish your homework, and you guys are going to have a quiz on this on Friday on lessons 10 and 11. So, and so that you can show me what you know and see where I need to reteach, if I need to reteach it all, or if I can move on. I would really like to move on next week and do another 2 lessons. The quicker we can get out of this unit, the faster we can go to the next. So, okay, guys, let me know if you have any questions, and I'll talk to you soon. See you on the Zoom today.